Calvin Chastain at the Champlain Meeting House. We're out 9 in Village of Champlain, and we're here on this February 9th for a meeting that's getting an overflow crowd packed into this very popular meeting house here in the downtown area. The guest speaker tonight is Dr. Raymond Johnson, who's going to talk about a subject that we're all very familiar with, climate change. And it seems like we have weather changing all the time, but up and down winter here in 2019, but weather and climate are two different things. And we're going to know what he thinks about all the climate change that's happening and has been happening for the past several decades. Tough crowd.
I know you all came only to talk to each other. Sorry. Nothing like the meeting house to socialize. It's the primary focus.
It's a small area.
Okay, so thank you all for coming. I'm very excited to be able to have Ray come talk with us today. And he's going to do his own introduction. I said I wasn't very prepared for that. But thank you all, and thanks for coming to the meeting house.
You bet. And thank you, Janet, for the opportunity. Just by way of intro, I worked for Wyatt for 30 years as a chemist, as an analytical chemist. And starting around 2002, I went to my first climate conference. And I kind of got hooked on the science because I really enjoy the science. It's very interesting. And starting in 2009, I managed to convince the Press Republican to accept an article. So since 2009, I've been writing articles for the Press Republican. So this next month will be my 10th year with them, 120 articles.
Yeah.
So feel free to ask a question at any point. This is not a formal presentation so much as it is an attempt to share a lot of data with you, a lot of information.
Where was your first conference? You said you went to...
I went to the Nature Conservancy conference in the Adirondacks,
Okay.
and it was down in Sagamore Hotel. And that was probably the first time I heard the term climate change. Yeah.
And the year was what again?
2002.
Okay.
So I've been really engaged with it ever since. More so in the last 10 years than prior. So Janet is here, no need for introduction. But I want to concentrate on the science and the data and then the impact of the science and what's happening to our atmosphere at this point in time. So I want to give you some perspective and then some science, and then some extreme weather events, which we're experiencing now. We've had 2 freezing rainstorms in the 20-degree temperature range in 1 week, and then some solutions in technology. Again, please feel free to ask a question at any time. Okay, so in terms of perspectives, this is the biggest or longest selfie that I'm aware of. Here you are. Here we all are. And that is Earth taken from underneath the planet Saturn. And the controllers in Houston turned the spacecraft cameras around to take our picture, just for perspectives. So that's almost 1 billion miles away. And the reason I have that there is to show you that there's no planet B. There is nothing, there's no other place that we can go to. That's our home, it's the only one around, and we have to take care of it, in my view. So, this is a very famous photograph taken by the Apollo astronauts in 1968. You may have seen this before. And when they circle the moon, this is the moon's surface here, they had Earthrise. And that was the first time that anyone on Earth saw a photograph of what we look like from space. And obviously it's got green and white and blue. It's got a lot of life and a lot of complexity. So the science, the Earth's atmosphere. So right now, the air that we're breathing is about 78% nitrogen and 21% oxygen, fortunately, because that's what we need for our biological processes. And then there's a trace of other stuff. And that trace of other stuff is largely carbon dioxide. It has some other gases in there, helium, ozone, methane, neon. Has a variety of other substances in it, but primarily it's these two gases and carbon dioxide. So here's what we're talking about, right? This is Earth, and it's about 8,000 miles across, 25,000 miles around, but you can't see the atmosphere. This was taken from a satellite about 25,000 miles away from Earth. And you can't see the atmosphere because it's so thin. It's only maybe 10 miles thick. 90% of the atmosphere is within 10 miles of the surface of the planet. So with 8,000 miles, you really can't even see the atmosphere. But the atmosphere is absolutely critical, of course, to weather and longer-term changes to weather or climate. Come on, here we go. So this is what we're talking about here. This is, I've got a couple photos of the atmosphere. And this is Earth here and the atmosphere, and it slowly thins out as you go up. And the different colors in the atmosphere are pollutants or particles from diesel or automobile exhaust or volcanoes, whatever. So this is where all of the weather and long-term climate takes place. This I just got about a week ago off the web, and again, it shows how thin the atmosphere is and how it slowly has a gradation into basically nothing, into outer space. And I have one more here. This is from the space station, and you can see how thin the atmosphere is. I mean, you can see stars through the atmosphere from 200 or 300 miles in space. So again, it's thin, the composition is really important, and that's where all the changes that we see take place. So the greenhouse gases consist of these. The primary one is carbon dioxide. And there are others, such as shown here, and there's some others like hydrofluorocarbons, for instance. But the primary one is carbon dioxide. So what is global warming? What causes it? Basically, greenhouse gases, what they do is they're in the atmosphere, as we saw before, and the sunlight comes through, hits our planet, and then heat, it warms up the planet's surface, and then infrared energy is emitted from the surface, just like when you're in front of a stove. And so what happens is that a lot of that heat goes off into space. Some of it does not, and it's what allows life to exist on our planet. And what has changed, though, is the fact that we're burning lots of fossil fuels. And so what's happening now is instead of the energy coming from the surface of the Earth going out into space, it's returned to our living space. So the 2 hours now are coming back down. So that's basically it. It's very, very straightforward, very simple. So here's carbon dioxide. For those chemists in the audience, if my head was carbon, and these were oxygens, what happens is that these things are always in motion, and up and down, in and out, and those frequencies that they move around are what absorb the infrared energy. It's just plain chemistry and physics. It's nothing complicated about it. And that is unique to carbon dioxide and some of the other greenhouse gases that we looked at. So where is the greenhouse gases coming from? Primarily fossil fuels. Coal, oil, and gas. And if we look at coal, this is a coal seam. And you can see the overburden up here, which is where it's removed by big machines. And then this coal seam here is then tapped. You can see the color in here. Some of that is sulfur. And so when that coal is burned, a lot of that sulfur is what caused the acid rain, and for most of the Adirondack lakes to turn acidic and basically devoid of life as we know it. There are some microorganisms there, but very few fish or frogs or crustaceans. So this is a coal seam. And this is probably in Colorado. I don't know the exact location. Some of them are thicker, some have more overburden above them, but that's basically what it looks like. And so it's mined, and this is a coal train. And it's almost a mile long. And most of the coal goes to power plants, where it's burned to generate energy to make electricity. We consume hundreds of millions of tons of coal per year. And the carbon dioxide from that combustion goes up into the atmosphere. So that's one source of carbon dioxide. Another is oil. Now this tanker here is about 3.5, it says pitches, football fields long. So it's about 1,000 feet long. And holds 3.1 million barrels of oil. Now every day, we burn about 95 million barrels. So we fill up about 30 of those tankers every day. And that's what's consumed. And when you burn a barrel of oil, you get a lot of carbon dioxide being given off. So these are the two major sources of the carbon dioxide that we have in our atmosphere. So the world consumption right now is about 95 million barrels of oil per day. So a real big field that the oil companies may discover of 1 billion barrels, that's used up in 10 days. Which is why they're always looking for more. Any idea what this is? Any guesses?
City.
It's a city of some sort.
It does look like a city. I thought it was a city. What it is are fracking platforms in Colorado. So each of these rectangles here is a fracking platform where they go down into the layers of the particular rock of interest. And then they send out side pipes, and then they put in various materials to separate the rock and allow the gas and oil to escape. So this is Colorado, western Colorado. And when I saw it, I said, oh, I thought it was a city street. So it just shows you the extent that we're going through in order to get the energy that we need.
Is that gonna run out someday?
Yes. Yes.
Can't that cause earthquakes?
Actually, they are finding that the fluids that they get back up from the well, they don't know what to do with it all, so they've been putting it back down some wells. And yes, it lubricates certain areas of the rock formation, and in Oklahoma in particular, there's been a lot of earthquakes.
Is it polluting wells in the area?
Yep.
I was under the impression that fracking was no longer allowed.
In New York State, they haven't allowed fracking. Pennsylvania and most of out west, Texas and New Mexico, Arizona, Colorado, yeah, they do a lot of fracking. Yeah, we're lucky that our governor made that decision 5 or 6 years ago that it banned fracking. Yeah. Okay, so what do we have here? We have basically 400 million years worth of material that was formed over geological epochs, and in 2,000 years we burnt nearly half of that. So it took 400 million years to create it, and in 2,000 years we burned it, most of it in the last century. So we're taking this stuff that was underground and putting it into the atmosphere and changing the nature of our atmosphere. Okay, so one of the techniques that scientists try and do is understand what the atmosphere was like in the past. And so what they did is go to Greenland. Now this young lady here has got a weather balloon. She's standing on 2 miles of ice. So there's 10,000 feet of ice underneath her feet. And so scientists thought that, well, gee, maybe the ice has some secrets that we can use to find out about past atmospheric concentrations of greenhouse gases, specifically carbon dioxide. And so that's exactly what they did. And, come on. This is a series of photographs of one of the early drilling rigs. And so this person is operating a drilling rig, and you can see the cable going down. And here's the hollow tubes that consist of the ice core. It's got teeth on the bottom, and so they push it down through the ice, drill through the ice, and come up with a core. And that core then has layers in it. Each year that it snows, it falls. More snow the following year, and it falls, and so forth. And so that cylinder of ice is a history of what the atmosphere was like when that snow fell. And so here's the surface, and here's the ice core borehole. And so the World Trade Center is this high. You can see how far down they went. And they went down almost 2 miles. So here's an ice core. So what do you think happened here? This black line. What would have caused something to go into the atmosphere to fall on top of the ice? Yeah.
Volcano or
Yeah,
something?
exactly. So this contains traces of events that happened on the surface of the planet over a period of many years. And you can see some other gradations in here, but that's obviously a volcano. And this person is marking off layers so that they can march back in time. So they count the layers from the top and go back in time, and so they can go back a couple 100,000 years by counting the layers in that ice. And then what they do is they cut it into sections and analyze it in instruments. So this is under the ice, because they couldn't have a laboratory above the ice with the winds blowing and so forth. So they actually made a cavern, put their equipment in there, engineering equipment and so forth, and analytical equipment, and did a lot of the analysis right there. So this is what one situation looks like under the ice in Greenland. They then save a lot of these cores, and this is in Colorado. So they fly into Colorado, store them at minus 30, so that they can continue to do more research on the ice cores. And they have thousands upon thousands of these tubes that contain the ice from these experiments.
You know when the first year was that they took one of those samples?
The first year was about 1995, thereabouts, and it was done by Denmark, because Denmark is the governing body of Greenland. Yep. And those photos are of the original rigs, and they're from the 1990s. The new ones are much more sophisticated. So in an ice core sample, when you section that cylinder, here's what they look for, are the bubbles, the gas bubbles. And so the instrumentation they have, when they put that into an instrument, they'll be able to tell what the composition of the different molecules are in that air bubble. And then from that, you get data, you get information. So here's the temperature here, and up here is the carbon dioxide concentration. So this is 800,000 years worth of data. So there's a lot of students, a lot of people did an awful lot of work over a couple of decades to acquire this data. So what they found, and they can measure temperature by isotopes, different types of oxygen, different types of carbon. And we won't get into that tonight. But basically they can look at the isotopes and make an estimate as to what the temperature was. And so you see the temperature goes up, comes back down. So when it comes back down, that's an ice age. This is where we would be like now. This is 0, so that's today. And so this is where we are today in terms of temperature. And you can see that it wasn't too long ago, maybe 15,000 years ago, that there was over a mile of ice where we sit right now. And so that was the height of the ice age, and then the ice began to melt. So what they found was that the Earth has gone through these cycles before. And they found that there was a very good correlation between carbon dioxide levels. When carbon dioxide levels were high, temperatures were high. When CO2 was low, temperature was low. And you can see that here, CO2s are high, temperatures are high, CO2 is low, temperatures are low. So they found a very good correlation between carbon dioxide concentrations and temperature over the last 800,000 years. Okay, so what we have here is that same data. Now this is just CO2 concentration over this period of time until about the year 1800, but here's where we are today. So we are far different today in terms of our concentration of carbon dioxide than any time in the last 800,000 years. And actually we're up about 410 this month. So brand new territory, brand new territory. About 10,000 years ago is considered the start of agriculture, when we went from hunting and gathering to towns and farms. And the concentration of greenhouse gases then was about 265 parts per million. And it stayed that way pretty much, increasing a little bit until now. And now, of course, again, you can see the big change since we became, quote, civilized and lived in towns and had farms. This is the longest, this particular station at Mauna Loa is the longest running laboratory on the planet that measures CO2 directly. So they take in the gas, they have instrumentation, they measure the amount. There are others now that exist, but this one in Mauna Loa has been the longest one. So you can see this spike here. You might want to know or have a question, why does it drop? Well, in the springtime when buds come out and leaves grow, the carbon dioxide concentration drops. In the fall, when the leaves fall off the trees and we still continue to emit CO2, the levels go up. So this is a seasonal pattern caused by the planet. It's like it's breathing. And it's been very reproducible for all of this time. And there are some questions that people ask, well, how do you know that the carbon dioxide is coming from us, from the air? Well, what scientists began to do in the 90s was measure the actual amount of oxygen in the air. And they found that the amount of oxygen in the air began to decrease at the same time that carbon dioxide began to increase. So there's a direct correlation between the oxygen in the air and the decrease of it and the appearance of the oxygen in the carbon dioxide. So the air you're breathing today is different than it was in 1995. And before that, obviously, but they just don't have the data for it.
Well, right, with fewer trees, I know we've heard stories about the Amazon and so on. Isn't that helping to do this too? I mean, more of us are breathing now than ever before, so we're using that oxygen, and now we haven't got trees producing it. So isn't that part of it too?
There's a big concern about the Amazon, and you're absolutely right. The cutting of the Amazon forest there is going to be producing a lot more CO2, and it will be trapping less CO2 because there's less trees to go through photosynthesis. So there'll be less carbon trapped in the trunk, in the trees, and so forth. So yes, that's a big concern. And the correlation. This is the instrumental record from about 1880 to current. And as the instrumentation shows, that the CO2 levels go up, the temperature goes up. So there's a direct correlation between, another measurement of it, a direct correlation between temperature and CO2. Okay, but CO2 is really important. We need it. We like our trees, we like our lettuce and Brussels sprouts, and all animals depend on it, at least animals that are grazers. So here we have that delicate balance between what is a level that is good for the planet and what a level is that is not so good for the planet. Okay, so what accounts for these ice ages? We saw those cycles where the temperatures went up, went down, went up and down. So basically, this is the way we travel around the sun. And we travel around the sun not in a perfect circle with us in the middle, but we're off to the side. So it's an elliptical orbit. So that's why right now the sun is actually about 3 million miles closer to us right now than it is in July, because of this elliptical nature of our orbit. But we're not facing the sun. You notice how low in the sky it is. In the summertime, it's much more overhead, and so there's a lot more energy coming into our summer in July. And so this is what helps account for the change in the seasons, and it's caused by this ellipticity of our orbit. So when you hear, well, it's always changed in the past, that's true. That's very true. However, what's changing it now is not the nature of our orbit, it's the nature of the composition of our atmosphere. So there's these 5 components that consist of the climate system, and they're pretty obvious. And here they are here, the cryosphere, the ice, in the Himalayas, the water, the biosphere, like you were talking about, Calvin, in terms of the green, and the atmosphere, where all of this mixes together. The geosphere is also important from the standpoint of volcanoes. Some rocks absorb carbon dioxide, some give off carbon dioxide, so they all interact together. So it's a very complicated system. The planet is about 70% water. So there's only about 30% land that we have. And so one of the big unknowns is, what's the temperature of the oceans? Where is this heat going from the greenhouse gases that we have in our atmosphere? So some time ago, about 15 years, maybe 20 years ago, they began to put these what they call Argo floats. And they're pretty sophisticated instruments, and at the present time they've got, I forget how many they got now, it's somewhere around 5,000 of them that they've made and dumped in the oceans all around the planet. And what they do is they go down through the levels of the ocean to a certain depth, capturing data as it goes down, mostly temperature data, but other components like salinity and so forth. And then it shoots up to the surface and broadcasts it to the satellite. And then it goes back down again. So you have these floats that continually monitor the temperatures of the ocean down to about 6,000 feet. It's 2,000 meters, so it's better than a mile deep. And from that, they found that a lot of the energy, and I'll come to that in a minute. This is one estimate of where the floats are. And what they found was that a lot of the ocean heat goes to 2,000 feet, and a lot goes to 6,000 feet. So if the oceans were not here, we would have an atmosphere that would be too hot to live in. Fortunately, the oceans are absorbing a lot of the heat, as you can see here, and moderating the impact of the extra CO2 on our atmosphere. Any questions about that? So the oceans are absorbing about 93% of the extra energy in our atmosphere, fortunately for us. This is a temperature index, and this is global land ocean, and you can see that there is a big increase, and if anything, the increase is increasing as we continue to burn more oil, burn more coal, use more gas. That rate of increase is really beginning to change, starting in the 1960s, 1970s, in that area. So the 10 hottest years globally have all been since 2000, except 1998, but they've all been since 2000. And I just got this yesterday. These are the last 5 years. These are the hottest 5 years of measurements on the planet that they've obtained so far. And as you can see, the Arctic, this is Hudson Bay, here we are down here, the US. A lot of the heat is up here in the Arctic, which is what is causing a lot of changes in our weather patterns, like the polar vortex that you may have heard about.
What's causing that to concentrate in that area up on the...
Good question. You know, it's so new that there's a lot of research being done, and I'm not sure they know all the answers yet. I don't know the answers, but I'll show you a couple of slides here that may provide some information for you. Wrong way. This shows that it's not just the US that is measuring these temperature changes, but it's NASA. Hadley is in England. Berkeley is California, and also is another one from the Japanese Meteorological Association. So you have Europe, you have the US, and you have Japan, all agreeing that this global temperature change is occurring. So what's happening? Sea level rise. So this year, the oceans will rise about the diameter of 3 dimes. And next year, 3 more dimes. So that's about 3 millimeters a year. The ocean levels are increasing, and they have been doing that for a number of years. So every year, that's how much the oceans, which cover 70% of our planet, is going up.
How about the lakes? The lakes and rivers, would that also increase, or just the oceans?
This is oceans. Lakes and rivers are dependent on precipitation. And so precipitation varies, and so if it's a drought, they're going to go down. If it's not a drought, then it's going to go up.
Okay.
Yeah.
So has sea level changed?
So that's sea level change. The 3
Yeah,
millimeters
but
per
so-
year is a
so-
sea level change.
I know, so now, when you say sea level, it's a different height than it was 50 years ago?
Absolutely. We've
So-
gone up.
So
about
everybody
8
who lives
inches.
100 feet above sea level probably only lives 98 feet?
Lucky. We're pretty lucky here.
We're only 98 feet above sea level now,
Yeah,
instead of now?
you're right.
So we have to change all of our maps.
That is a possibility. Yes. So the sea levels have risen about 8 inches in the last century total, almost a foot. This is the median ice extent. This is the Arctic again. This doesn't answer your question particularly yet, but you can see that there's a lot less ice in 2010 than there was in 1981. So in 1981, this is where the ice was, and now this is what it is in September, which is the minimum ice extent for the Arctic.
Now, when the ice is gone up there, it's gonna be, the well's gonna start going dry down here after hundreds of years or thousands of years?
Probably not, because as the oceans warm up, the warm water gives off more moisture into the atmosphere, and more moisture in the atmosphere produces heavier precipitation events. That's why Houston had 52 inches of rain 2 years ago. So the rain in Houston was this high over a period of several days. I don't remember how many days. So I don't think it's going to dry down here so much as have variable droughts and variable amounts of floods. Right.
Do you have any statistics about the amount, not only when we burn the fossil fuels do we put carbon dioxide in the air, but we put particulates in the air like of soot, and when they come down, it makes especially if it falls on the snow, as you know, when you see dirt
Melts
dirt,
it.
dirty snow, it's gonna make the sun's rays absorb more of the heat
Right.
and melt the snow even faster. So
Very
do you
good.
have numbers on how much that's gonna happen? And also, I've read too that the warming of the oceans is gonna warm up the methane that's blocked into the bottoms of the oceans and release more greenhouse gases into the air.
You got it.
And my other question is on your other chart, where you showed for the last 800,000 years, it was cyclical. You had your points and went down. Do they have any theories as to why, when it got to a certain point, it would drop?
It was the cycle of the planet
Oh,
rotating
okay.
around the sun. It's called the Milankovitch cycle, and it's elliptical. And sometimes the Earth is closer to the sun, much closer than we are, and in other times it's further. Also, we have a tilt on the Earth's orbit, so depending on when that tilt occurs, it can influence the amount of solar radiation that hits us in the northern atmosphere.
Okay, so that's, the whole thing was due to the astronomy.
Correct, yeah,
But those were 50 to 100,000 year cycles that,
that's right, it's about 100 to 125,000 years per cycle.
so if it's happened before, we've gone up, then we went down,
That
Why-
cycle will
what's-
happen again.
so we will go down.
Superimposed on the cycle we are creating, yes. Yep. Yep. So you asked about the ice, or about the fact that we're losing ice in the Arctic and what's the impact. This shows what they call the albedo, which is the amount of energy that's reflected off the ice. And as you know, snow and ice reflects energy. And with less ice, you're going to absorb more energy into the water. And so the albedo of the Arctic is about 90%, which means that about 90% of the energy on the ice is reflected back into space. That's the way it used to be. Now it's almost in reverse, because now we have dark water, which is absorbing the energy rather than being reflected. So that may in part account for the fact that the Arctic is warming faster than the rest of the planet. That's one reason. Greenland is losing lots of ice, so here you have just 0.0 and then billions of tons. Greenland is continuing to lose lots of ice every year. And you probably have seen this on television, or chunks of ice falling off of an ice cap. So Greenland has an enormous amount of water on its surface. As I mentioned, it's about 2 miles thick, and it's losing a lot of mass every year. And the same holds true in the Antarctic. They're losing ice mass as well. And yes, the sea ice extent. So in March, at the tail end of the winter is when maximum sea ice exists. That's when you're coming out of the 24 hours of darkness. And in the fall is when it is at the end of the warm period in like September, October. And so the average monthly sea ice extent has been dropping. Again, it just reinforces the other graph showing the albedo effect and how more open water absorbs more energy. This is the Muir Glacier in Alaska in 1941. And just note these mountains here. This is it today. This is Kenai Fjord. It's a national park in Alaska. And again, it's a little hard without comparing them side by side, but this is around 1910, I think. And this is what it looks like today. So we're losing a lot of glacial ice. And it's not just in Alaska or the northern hemisphere. This is in Argentina. And this is the Ipcc Glacier in Argentina. So this is the Andes, And you can see the big change that's happened in the last 70 years, 65 years. It speaks for itself. Okay, polar vortex. Jennifer Francis was at Rutgers University. She's now at Woods Hole Research Laboratory in Woods Hole, Massachusetts. And she came up with this, and there's not total agreement yet. They're still studying what's going on because it's so new. But generally, the jet stream circles the planet at hundreds of miles an hour in a fairly tight ring around the top of the planet. And it separates the cold Arctic temperatures from the more moderate temperatures where we are. What's happening now is that the polar vortex is beginning to lose its structure. And so last week when Chicago was minus 30 or Detroit was minus 25, that's very unusual and it broke all kinds of records. And that's because the structure of the jet stream has changed and it has these bulges in it now, bringing cold Arctic air down into the interior of the US. So it's not unusual for Alaska to be warmer than Chicago because of the nature of these loops in the jet stream. This is the most recent one. This was the 5-day period last week. Actually, it was the end of January. And you can see the big polar air mass coming back down because of the polar vortex. So that's a 1 week's worth of data from NASA.
There again, do you know what year that polar vortex term actually came into?
No, I don't know.
Because I know 30 years ago you never heard the term.
No, I suspect it's fairly new.
Exactly.
10 years maybe?
Yeah, and it's this lady you were talking about that kind of coined that phrase?
I don't know that she coined it.
Okay,
I
that's,
think,
She's been studying
I
it.
think last year we started hearing it on the news all of a sudden. That was
Have
a
you?
new term,
Okay.
the catchword was the polar vortex. So
Yeah. It's fairly recent.
and there's another word to use too, it's similar to it, I can't remember exactly, it's another inversion or some type of deal, but
Okay.
I don't know if you know what the other term I'm
I
thinking.
can't think of it offhand.
Okay, but anyway,
Yeah. No, it is a recent
yeah,
term.
that's what I thought.
And you are beginning to hear it now on the Weather Channel and so forth. Yeah. So what happens when you get a polar vortex and you have one of those bulges? This is Rome. Normally you don't think Rome. Normally Rome does not get snow. This is Niagara Falls, and this is about 3 years ago. And this gentleman climbed up Niagara Falls on his pitons. He was belayed from the top by his girlfriend, and he climbed up with an ice axe and pitons that he stuck in the snow, in the ice. So I think we've all heard about extreme global events, whether it's heat waves or floods or lake ice reductions. All kinds of impacts are being noticed by us and by weather people in terms of events, global weather events. And in 2018, this just came out a couple weeks ago, there were a number of billion-dollar disasters, and I think there are about 13 or 14 at the counting. And they are everything from fires to, these are brush fires to
hailstorms.
hailstorms, thank you, to tornadoes, to snow. So it's a whole variety of things, but it's beginning to cost us and cost insurance agencies a lot of money. And so insurance rates are going up. And they monitor this carefully. They don't want to lose money. And the often asked question is whether that event was caused by climate change. And this gentleman here is at the National Center for Atmospheric Research in Colorado. And what he said is that all weather events are affected by climate change because the environment in which they occur is warmer and moister than it used to be. So it doesn't necessarily cause a flood so much as that event that happened is now enhanced by climate change. This is Tennessee. This was 2 years ago. And Tennessee had some major forest fires, something that I haven't heard of. But this is Tennessee. And these houses look very familiar to us now after California this past fall. But this again is Tennessee. They're incinerated down to just basically nothing.
My mother lived in Paradise,
Oh, did she really?
but I moved her out here in '98.
Good for you. Wow.
So, and the rest of the family are all from Paradise that are here now
Uh-huh.
that resulted out of me moving my mom here.
Wow.
So, it hurt the young ones because they went to school there.
Uh-huh. So what they had been living in is gone now?
It's all gone,
Yeah. Yeah.
nothing left.
That was a good decision.
But as long as Mom lived, it was, the rest of the time was here.
Mm-hmm.
And I brought her out right after the ice storm,
Oh, is that right? Okay.
so. But it's hard for just the rest of the family to see Paradise just
Sure.
isn't there anymore.
Yeah.
And it's,
That was a city of about 10,000, I think.
and it was built to be senior citizens
Uh-huh.
and, you know, at the end of life to live there
Right.
and, but it got more popular and more popular until
Yeah.
everybody was there. But, yeah, it wiped out the road my mom was on. So, yeah, I'm thoroughly happy that I've got my family out here and we don't have to worry about that.
Right. No, I've often mentioned to Lola that I feel very fortunate. I mean, we may have ice events like we're having now, or a big snowstorm, but we don't normally get the tornadoes. We don't normally get 4 feet of rainfall. I'll show you later on, we do get some rainfall. But generally, wind and other events are pretty moderate here, so we're pretty lucky. This is in Louisiana. They had about 30 inches of rain outside of Baton Rouge. This is Highway A1A in Florida 2 years ago. I'll be curious to see what they did to this, whether they filled up sand, dredged sand from the ocean, or moved the houses back. I'm curious to see what it looks like today. I don't know. But anyhow, you can see the infrastructure damage that's occurring. This is in the Houston area after a major storm. Now that's a novel way to save your family.
Ingenuity.
And this is in, I think, Peru. Yeah, it was in Peru.
Yeah, that's mud.
And this is in Australia. They had a series of rain events there in northeast Australia, and it covered a part of Australia larger than France and Germany combined. And this is in Thailand. This was a car factory, and they had their cars stored there, ready to be shipped to wherever. And then the floods came and destroyed what you can see here. In addition to floods, of course, we have droughts. And this is the Amazon River back here. You can see the bridge going over you can't see the river, but that's what it would be doing. This is the Rio Negro, which is a huge tributary into the Amazon. It is dry as a bone. And they estimate that over 1 billion trees died as a result of that drought that they had there. And the implications of losing that number of trees in terms of it's not fixing CO2 anymore, the dead trees are releasing CO2, so it's a double whammy from a climate point of view. Any idea without reading that? This is Syria, this is Damascus. And so these people are refugees, most of them, and they are waiting for food from the UN. And what happened in Syria is that they had about 4 or 5 years of drought in a row. And so the farmers would plant their grain, There would be a drought, very little or nothing grew. They would plant a little bit more grain the next year, and that didn't grow. And so they had no place to go. They lost their animals, they were not growing any crops, and so they went to the cities. That, in part, is what started the civil war in Syria. And then, of course, the policies of the government there were not very constructive. This is Joplin, Missouri, after a tornado. This was an F5, which is the most powerful tornado you can get. It stripped all the bark off the trees, including the smaller branches. And when people went back to the neighborhood to try and find their home, they couldn't find it because everything had changed. There was no landmarks that they could find. And there were 151 dead in this particular event. And this is Hurricane Sandy. This is kind of an interesting satellite photo because you can see this weather front here. And here's Hurricane Sandy spinning off the coast of Florida. And then there's another storm off of northeast Canada. Here's Nova Scotia and then Newfoundland. And so as Sandy came up the coast, it had nowhere to go. It couldn't go out to sea. It was blocked here. It was augmented by this pressure, this weather front that came in there. And so that's what created the damage in the New England area. Here it's really gaining structure. And here's that front from the northwest. This is New York City. This is down by the Battery. And some people, you had the underground parking there. So someone had the bright idea, well, maybe we better get our cars out of there. And so these people are going upstream to get out of the flooding that was going on in the underground garages. This is Brooklyn. There was I think it was an electrical or a gas fire in southern Brooklyn. And it burned over 100 homes. It looks like a war zone.
That's Breezy
Breezy
Point.
Point, yeah.
Queens, that's Breezy Point.
Oh, is it? Okay.
Yeah, because we have friends that live there.
Oh, okay.
Yeah.
This is a perfect trifecta, if you will. So this is in northern India. And in addition to climate change that causes a lot of precipitation, you have a lot of cutting of forests that happens on these steep hillsides. And so there's less forest to hold back the water. Then you have population pressure that cuts down those trees. And then you have an event like 2 feet of rain. So when you talk about climate change and then growing population and then resource extraction all coming together, this is what you get. And this is another picture here of northern India. And these homes or these buildings have been there a long time, and you can see that this is a new event that happened. So when you combine these different things going on, it's really causing a major impact in terms of on property, on lives. That's an evil eye, and that's they call them typhoons from the south of the equator. Hurricanes are north of the equator. So this is Typhoon Haiyan, and it hit the Philippines with a vengeance. And this is the town of Tacloban, and this destruction is obvious. But Long Island, there were 13 inches of rain in a day in Long Island, and it interrupted, obviously, the commutes of tens of thousands of people and so forth. So that's the Robert Moses on Long Island. This is interesting. This is Alaska. This is where they do the Iditarod. And there was no snow in 2014. And before they do the Iditarod, they have a bicycle route or bicycle race on the same trail. And so you can see he had his fat tires here, but there was no snow. And also in 2015, there was no snow. And this guy is putting his sled dogs in a truck and driving another 100 or some distance north to find snow, so he could get his dogs in shape for the Iditarod. And then in order to start the Iditarod, they use a train to transport snow into the town so that they could take off. Yep. And then you have Boston. This is 3 years ago? 3 years ago? 4 years ago? They had over 100 inches of snow. I'm not sure they broke the record, but it came very close. That's part of the polar vortex.
This year they only got 3 or 4 inches
Is that right? So far.
so far. Right.
And the same thing is happening here in Africa. This is Senegal. And the ocean levels are rising. And the storms coming in from the west are eroding away the land mass. And so it's causing a displacement of people and property. Okay. Any guess where this is? Don't read down here. That's Vermont. That's Lake Champlain. So the New York shore is over here. And these two people are standing on a dock on the Vermont side. And this was during Hurricane Irene, Tropical Storm Irene, I believe. And Tropical Storm Irene occurred in a year in which there was a lot of snow in the Adirondacks. And then there was a lot of melting and rain that occurred, and the lake level rose to very high levels. And in those, so here's the lake levels over the last 100 years. And so in 2000, the record in May was about 100.6. And this is 2.6 feet higher than the 100-year record. And so this is in the springtime. And then Irene hit in the fall. So you have a high lake, and then you have this tropical storm Irene coming through, and it caused an enormous amount of property damage along both sides of Lake Champlain. So there's a lot of data here, but it's interesting to see the way the pattern works, and then these are the records here, 2011 are the records, and it just exceeded by a large margin the previous 100-year record. Lake Champlain freezing dates. So this is almost 200 years worth of data. And you can see in the first 100 years to about 1920, 1930, it froze over every year. So the years that it didn't freeze over are by these triangles. And you can see how much that's changed in the last 30 years. This was Puerto Rico a year and a half ago. And El Yunque, the national forest that they had there, that was the sanctuary for a lot of wildlife and so forth, is basically gone. And typical damage from a hurricane is still not back on their feet. Here's where Hurricane Harvey in Houston. So I don't know exactly, but that's how much rain fell. So what do we do? There are solutions. And right now, from the sun, we're getting an enormous amount of energy. Even though it's dark here, it's light somewhere else. So we're getting about 23,000 terawatts, just a unit of energy. World energy consumption is only 16 terawatts. Pretty clear what we need to do. We don't have to burn oil. Right here. Other renewables are listed here. Wind is a good source, but the sun is giving us this much. So those are fossil fuel and nuclear over there, and it gives you some idea how big by size, how big a reserve of energy they have. But the sun is giving us this right now. Solar installations in the last 6 years, well, in this 6-year period anyhow, grew by 22-fold. And it has continued to grow a lot. Globally, you can see it started off really small, very little. And then as the price of the panels got less and less, the installations went up. And so it's very encouraging to see the amount of cumulative installed solar there is globally. Because right now it's up to the ceiling. And we hear a lot about China, but China's trying real hard to do a job on their atmosphere for their people, and they're investing an enormous amount of money in wind power. I said solar, it's wind power. And US is next, and then Germany and some of the other European countries are following. Denmark has a plan. They want to be energy neutral by 2050. And so they have offshore wind, they have onshore wind, they have solar panels on houses, they have commercial solar power, they have commercial solar power, they have heat pumps. So that's their plan, and they hope to become energy neutral in the next few decades.
It's heat pumps taking heat out of the earth.
Yes.
Isn't that a little dangerous too?
In what way?
All that heat's in the earth and we're taking it.
I thought about that.
So they ain't there no more. Just like the fracking is dangerous for obvious reasons, and I'm just wondering about stealing the heat from the
That's an
earth.
interesting point. I don't know the answer to that. Yeah, I have to think about that. Yeah. There is a group that is trying to figure out what we can do in New York State. This is mostly New York State, but also US. So this is all fossil fuels here. So what can we do to reduce the amount of fossil fuel consumption? And so they're looking at wave and tidal, onshore wind, offshore wind, and so forth. So there is planning going on to try and reduce the consumption of fossil fuels. And you can see it, the plan is to try and get to 2030 with a big reduction in the amount of fossil fuel consumption.
What about electric cars? Does that help? Would it cost a lot more to build with the batteries and stuff?
Electric vehicles are generally considered to be better than internal combustion engine. Even though they require electricity, the electricity can be made up by wind and solar, and that's clean energy. Yes, the batteries are expensive, but the prices are coming down with the batteries a lot. And they are still an expensive part of the vehicle, but the Chevy Bolt, I think, is around $35,000 thereabouts. The Tesla Model 3 is about the same price. So they're not cheap, but they're also being made for the first time. And so it takes a while before Detroit gets comfortable with making something different than an internal combustion engine.
But we've got a Ford C-Max, and right now we're running a little bit over 63 miles per gallon.
Wow.
And in the wintertime, summertime we'll go up to around 67 because we're using the heat. In the winter, I don't use the heat, she uses it. She says it's cold out. I sit in the car, it doesn't bother me, just like this, even in the winter.
That's great mileage.
Yeah.
Yeah, no, that's great.
How long does it take to charge your battery though? If I pull up to a gas pump, I can be out there in 5 minutes, but...
Oh, we just plug it in
Well,
at
it's a
night.
hybrid.
It's a hybrid.
It
Yeah, yeah.
uses both.
Yeah, but
We
these
plug it in.
Teslas, I know this...
No, we're not chargeless.
Yeah.
Well, we plug it in at night, charge it up, we get up to 25 miles, like, it's not free because you're paying electric to charge it, but it's a lot cheaper than buying gas. Then after that, but we're still averaging, in the summertime, we'll run up to 67 miles per gallon.
But you raise,
Yeah, I just
well,
want to know
you raise
how
an
long.
interesting point, and that is, there are a lot of charging stations in the United States now, but it's not as many as there is gas stations.
Yeah, but
And it does take longer to charge a car. And they're working on 3 different levels of charging. The third level, theoretically, you can go into a rest stop and get a cup of coffee, and in 40 minutes your battery will be recharged. That's not widely available yet, they're still building it out. So it is an issue for long distance driving. Around town, it's much less of a problem.
well, in Montreal this past week, they were talking about Tesla vehicles crawling through the tunnel because they were out of power because of the cold weather was drawing more.
Interesting.
And if you run out of gas, well, somebody can bring you a gas can, but if you run out of electricity,
It's a long power cord.
it's
There's no
20
free
below.
lunch.
Yeah, no,
There's
but
no
it's 20
free
below
lunch.
zero. So, unless, if you could switch batteries, like if your flashlight battery's dead, you can put another one in.
Right.
If that type of situation was available, I think it'd be more practical to go
I
with.
think it may happen to someone once, but not twice, that they don't plug it in at night. That you start off on your commute with a full charge, but interesting point.
Well, the gas tank on a car holds 12 gallons. It will run over 600 miles in the summertime on a tank of gas.
Yeah, that's really good.
You got all these big,
Depends on the way you drive and the car. No, but also, when I use it to commute, to go to school and come back, it usually, I can get to some of the schools that I sub at and get all the way home without using any gas at all, and then I plug it in. So that increases the mileage.
Right.
But then if you decide to go for, go to visit my family in Albany and you hop on the Northway, that's a whole different ball of wax. But we've got hybrid, so we, as long as we've got gas in the tank, we can get there.
we go wherever we want.
I was talking with a gentleman at the Honda dealer, and they have a model called a Clarity now. And the Clarity is a hybrid. And he recited the story of one person that bought a Clarity. And he said he only lives about 15, 20 miles away. And it goes about 45, 50 miles on a charge. And he said he hasn't used any of his gas yet, and he was worried that the gas was getting stale. So he came in and had some stuff added to his gas tank, so his gas tank.
He's gotta take some trips every now and then.
This is the Ipcc, and this shows the number of countries that signed off on the accord. And this was a reinforcement of that. This is in Marrakesh, Morocco, in 2016. Now, just a little bit of artists, a little bit about artists. This woman here, her name is Eve Mosler. She lives in New York. She lives in New York City, but a lot of her artwork is elsewhere. So this is the Brooklyn Bridge, and what she's doing is using something that you use on a ball field to put a line on the road. And what she's doing is marking off the height, the 8-foot mark in the borough. And so she goes down the street with this and puts that stripe in there, and basically this would be water and this would be land. And what it does is it encourages a lot of conversation. Like, people are wondering, what are you doing? And so she then begins to talk about climate change and storm surges and ocean level rise and so forth. So she's taking it on in a very different way. And so anyhow, that's what she has done. She's got an interesting website and a lot more photographs. Yes.
Batteries.
This is a gentleman named Sean Euro. He's a Hawaiian. He's a surfer. And he came into an interest in art at a later stage in life. And what he did is he goes around, in this particular case, in a kayak, looking for what he feels is a great shaped iceberg. And so he then paints a picture on the side of that iceberg. And this is what you call ephemeral art, because it will not last long, a day, a week, a month. But that's what he does to bring attention to the change in climate and to express his art the way he wants to. Here's another one. That's a painting on an ice floe on the beach. By him. This is a young woman. She's at or was at the University of Maine as a graduate student. I don't know where she's located now. But she incorporated a lot of those measurements that we looked at before, like ocean levels rising, number of wildfires rising, CO2 rising, amount of glacial ice and ice on the planet decreasing. So she's incorporated that into her artwork. And she has quite a few interesting pieces on her website. So her name is Jill Pelto. And this is a classic now. The title of this is Politicians Debating Climate Change.
Should put them in the ocean. Let them bottle them down in the ocean.
These are only about 4 inches tall, these figures, but he did a real nice job. So here's one way to communicate climate change. It's real, it's us, it's bad. Experts agree, and there's hope. And these are locations where the data that you saw I obtained from. So thank you for your patience and your time.
That lady's last artwork that you showed with the different charts incorporated into it. Yeah, I was thinking, there was one graph that you didn't show, and that was population, world population. Because you superimpose that on top of some of the others, and it's going to go up just like the temperature.
Yep.
Because
No denying that.
it's going up exponentially right now. And one other thing that it affects, that I've read about, is it affects the ocean currents, like the Gulf Stream, and that's going to affect climate in a lot of areas, especially like Europe. If the Gulf Stream moves away from the other, their milder winters will cease.
You're right, yeah. There's a lot of unforeseen changes, and certainly Europe could be impacted by a slowing down of the Gulf Stream. And there are some indications that that is happening now. So yes.
You know, Hollywood makes these movies and puts in all these special effects to sell tickets and stuff. There was a movie out several years ago called Day After Tomorrow. I don't know if you're familiar with it.
Yeah.
Could something like that actually happen at some time in the future?
From what I've read, in that period of time in which that movie took place and how quickly that freeze happened, the answer is no. But does it talk about climate change and what's going on and what could happen? It probably couldn't happen, but it gives you some idea of what could happen. But not to that extent. It wouldn't go to -70 or whatever it did in that movie.
Well, it was a good movie anyway.
It was an interesting story. Yeah, I saw that. Yeah.
Speaking of films, I'm sub for Scott Danville, and I haven't seen the film that his class a couple of years ago produced on climate change. Are they going to become available more generally so we can see
You'll have to
them?
ask Scott. As far as I know, they are available, but I am not positive about that.
Yeah.
He does show them to his classes at Beekmantown. And as far as I know.
Those are some films that I'd like to be able to show as a sub. I haven't seen them though.
I can give you his email address.
No, I have his email address.
Ask him about that. Yeah,
Yeah.
that'd be a good one.
I'm on his list of preferred subs.
Okay.
So when he needs what he calls me.
Okay. Yeah.
Any other questions?
Well, any ideas for small changes that you can think of that we could do? Yeah, I know it's not cut down the trees and stuff like that, but what can we do, Ray?
That is, that's a difficult question. I would say that the primary thing you can do is be heard, make sure you vote, make sure you ask questions about climate change. In our last presidential election, climate change was mentioned not at all, or maybe a minute or two in 2016. Even the New York Times had very few articles on climate change. Now it's almost every day they have something on what's happening globally in terms of climate. So I think the word has to get out there, and you have to be an advocate, and you have to vote, and you have to hear a voice. You can send letters into the editor, they're free. You're allowed one a month to the editor if you feel strongly about a particular issue. In terms of personal choices, don't buy a Ram 450. Walk to the post office or whatever. When you buy food, don't waste it, because they say that we lose about 30–40% of the food that we purchase or that is grown is not consumed. Beef is bad because of the clearing of the Amazon to grow beef. So there are some personal choices that you can make.
Packaging.
Packaging is one. Yeah. You could go online too, Sally, and look up particular things like that. And you know, you say light bulbs, well, yeah, you can get cheaper, you can get light bulbs that are much more efficient than the incandescent ones that we still use or are waiting for them to burn out. So there are things that we can do. The hybrids are a great way to go in terms of getting 67 miles per gallon. It's fantastic. So there are things that we can do, but I think the biggest one we can do is politically. We need leadership at the national level. New York State seems to be doing pretty good. Cuomo, in his State of the State message in January, committed New York State to having a high percentage of its electrical energy by renewable. And I forget what the number is, 40% by 2030, something like that, so it's pretty high. So there are certain things that are good in New York State, but it's not that way everywhere.
Less coal too.
Less coal, yes.
I think it's just very, it's very hard to understand how people can deny that and use that as a platform. You know what I mean? It's so clear when you look at the evidence.
Yeah.
I just don't see how we're gonna move forward when they're so, you know, so far apart on how some look at it.
Well, that's why you're here tonight.
Yeah.
That's why I'm here tonight. The idea is to share that information and try and get that word out.
How much of this is fluctuation, where it goes up for a while, then it goes back down? I know we're adding to it big time.
Well, we looked at the last 800,000 years and there was ups and downs. And that's going to continue to happen because that's built into the way we rotate around the sun.
But we're adding to it.
Now we're adding to it. And so we won't be back to an ice age very soon at the rate that we're going. Yeah. You had a question?
Well, not so much question, but most of us live in really old houses, and if people would insulate better, they would be using less
Absolutely
energy.
correct.
And yes, it costs money, but you're gonna save it eventually.
That's correct. Yeah. Yeah.
And it's really important.
I agree. So there's something that can be done?
Yeah.
There are a lot of things that individually and collectively that we could do to make a difference. And some of them are small, but collectively and additionally, they do add up.
Seems like it's so little of what we can do.
One candle cell.
Yeah, I know, but it's incremental. It's just so
It is.
But if everybody did it,
That's why we really need leadership, both at the county level and at the state level and at the federal level.
I just wanted to come back a little bit. That was Clark's idea, not mine.
So you're saving energy, is that what you're doing? Okay, well, thanks very much.
Thank you.
for your Sunday, what's about our
We'll wrap it up. Hometown Cable's visit to the Champlain Meeting House. I guess we're not going to see the sign in the dark. And talk tonight by Dr. Raymond Johnson. As always, views expressed are those of participants. Some people will agree with every word that was spoken tonight. Some people will have other opinions. But we thought it was important to cover this and find out what's happening globally. And if you have some questions, feel free to contact the experts. And we're no experts, so don't contact me. Thanks for watching.